Kevin is a WPI grad, robotics engineering in 2009, and has since gone on to start 2 local businesses. The first business is Neuron Robotics Cooperative, a robotics control solutions provider. And the other business is Technocopia. Technocopia is a 501c3 community tool share and makerspace. It's currently located near Bill, right down the hill. They are in the process of relocating to bigger and better space. So, and are you going to talk about Technocopia at all? All right. Anyway, we've had Kevin here before in a previous at a previous event. He gave us a little bit of an update and presentation about Technocopia, and it's really a fascinating endeavor that they have down there. A bunch of machine tools, a bunch of electronics fabrication equipment, a lot of people that are skilled in operating all of this machinery that can help inventors, help people that are trying to develop a product, bring that product to market. So just kind of a cool vibe too, and I think you'll get that as you listen to Kevin go through his presentation tonight. So.
We're going to give a little bit of a future channel and Ray Kurzweil wacky idea here. So as the last speaker, Bill, mentioned that the solution to this is going to be something nobody's imagined before. Well, let's imagine something nobody's imagined. So here's our problem statement. As open source ideas work their way into manufacturing, much of the manufacturing and retail industries are ripe for disruption. Producers that can produce at lower marginal costs will always have an advantage over producers that have with the supply chain, and labor as an overhead cost. Open source makes it possible for objects, materials, and automated production equipment to be free because they are at their core just information. Think of the robot that is a 3D printing machine. Not the products that come out of it, but for just the machine for a second. Open source manufacturing, it made its real disruptive debut with these machines. 3D printing itself. It drove the price of the machine from $250,000 for a printing machine to about $2,000 for a roughly equivalent machine 5 years after those prices were set. Now imagine what sort of price disruption the market will see as those printers start producing new products. New products and new distribution models. With robotics and software running whole production chains, we can form a synthesis of supply and demand through software communication medium. We want production to be like a tree. Have you ever thought about where tree comes from? Really thought about it, the tree itself. Chemically speaking, its materials come out of the air. Trees are mostly carbon, pulled from atmospheric CO2, and they're solar powered, as it turns out. We want to model a production, in fact, we want to model our production line on the inputs and outputs that your average tree would use. And use that as a template for a production system, with a focus for full automation to produce everything people need, and most of what they want, so long as it can be produced out of carbon and an automated production system. So how does it work? Makers have a desire to make things. I don't know if you've heard about this yet, but apparently we like to make stuff. We saw this work with the Linux kernel, over 1.5 million hours of donated work hour time. And that's just Linux. That's just one small piece of the computation systems that we use on a day-to-day basis. Many other successful open source projects, such as RepRap, a project built to make self-replicating rapid fabricators a thing, has proven that people will find meaningful work for themselves in open source projects, regardless of what they're told to do. Open source software has become open source hardware. And everyone can now share the products as information over the internet at no cost, just like you were sharing music files, and we all know how that went. With makerspaces, local robot production materializes the information that can be made anywhere in the world. So let's think about the model for a second. Libraries are about sharing access to information. Ultimately, that was the original point of the libraries from their inception. Makerspaces share access to physical information through robots. Makerspaces are bootstrapped through a gym membership model. Pay for the materials, pay for access to the space. But at the end of the day, there's a big picture here. You sell kits to found other makerspaces and fund growth, but those makerspaces now have robots too. And if they're following along with you, they have the biggest and best and brightest robots, the open source ones. This also spreads the load off of a single makerspace, making it more agile and responsive to demand, local production. And we're not just talking knit your own yams here, we're talking manufacturing local. Makerspaces can use grants for growth spurts as well as donations and selling kits of these robots like seeds for the tree. As costs are reduced, member fees are reduced. A little counterintuitive. Once production exceeds cost, focus is given to expanding the production line as opposed to the bottom line, stage one. We produce these seeds in surplus production until all the demand for the seeds themselves are met. So now you can imagine a little bit of what the nitty-gritty of inside this next generation makerspace looks like. Aquaponics production on one side, producing our ag and tech all in one, combining synthesis of the raw materials out of the biomass, food's an obvious answer, but also sugars to produce plastic, to produce resins for production board. Carbon fibers start coming out of this really quickly. And then the stage levels up and you have a new generation of machines. Graphene, carbon nanotube production. We're already working on a wet spinning filament process for making high tensile strength cables. Better conductivity than copper. Interesting. And finally, producing the robots and automation equipment necessary to automate that production, closing the loop. Now, of course, the competition is everyone. Literally all of everyone is doing it the traditional way. Maybe some asterisks to that, your Googles and your Amazons. But for the most part, the industry is in serial production mode. So, what do you get from that? You have a high variety of goods and materials and industrial production and global trade can provide. Luxury goods will ultimately always be produced this way, obviously. The whole point of the luxury good is the providing of this very fancy particular good from some expert that made it, some very specific geographic source of the object, or 13th century tapestries. I'm not going to 3D print those because they wouldn't be from the 13th century. But you can also start thinking specialty applications, big infrastructure, space exploration. That's the real goal. However, any mass production of items requiring labor in production or in transportation is a candidate for disruption by local automated production. Using direct software to communicate supply and demand information in robotic production as immediate and faster than using money as an information carrying system. So, how about the management structure? It's a global project of projects, meta project, if you will. The simplest way to describe it for the business community would be like the Zappos model. It's decentralized, it's global, but it's a movement of like-minded entrepreneurs working on interconnected projects. Open source projects have leads and contributors. Contributors to one project can be the lead of another project. Millions of work hours are donated on a yearly basis to open source projects. Do not for 1 second think this is just small hobbyists tinkering around. There are a few of those, but millions and millions of them. Researchers in academia push the boundaries. Hobbyists that love to program, and all of this production system is ultimately programming at the end of the day, make the ecosystem richer with each contribution that they make. And staff at makerspaces have a particular job of pushing the development towards practical machines that service their members' needs. So the role of the makerspace isn't just the place where the machines are, but is also the guiding force deciding which machines are put into place, what is the order, and how do we push these projects forward, as opposed to stagnating. With no external investment in makerspaces, they will achieve this goal anyway. Hitting zero marginal costs sometime in the 20-year boundary from right now. This project has been underway for years, since 2004 at least. The standard membership model is enough to cover the overhead cost and maintenance, some small staffing, but not fast-paced development. Now, imagine if this were funded like IBM hiring Linux developers, or the best case scenario, like the Edison labs of old, hired dedicated engineers solving particular problems. Development could progress faster. Each year, a new wave of machines would be released, potentially commercialized. A 5-year development is projected to result in a single vertically integrated production line with carbon-based materials producing outputs from a microscale automation on at least a single material. This starts knocking out materials costs, and after this point, costs start coming down over time as opposed to going up. Materials and parts chains are insourced. And by year 8, all components needed for the system to reproduce itself should be able to be made in-house. So the current status of this big global project is pretty impressive when you actually look at all the different pieces. Research that demonstrates strong results with batch lab processes, and this is sort of the interesting point, may never scale up to production simply because a batch process and mass production aren't necessarily the same sorts of things. However, our small batch design model can incorporate nearly anything produced in the research lab scale, since our model of production is focused on the small scale meeting the makerspace's members' needs. In addition to consolidation of existing technology, research work, a better set of design tools are in fact necessary, and we'll see a little bit about that in the demo later, to present this complex and interconnected production system. Also, a wider knowledge of makerspaces. Most people still, I have to explain what this is. I don't have to explain that here, do I? I'm just assuming everybody knows what that is, at least in this, since we had Nick a few days ago, or months ago. Oh, the days go by. All components of our production system, of this type of production system, exist in either deployed technologies or in research labs currently. All that stands now is a concerted effort to pull all of these technologies into a single pipeline. Questions?